Hello. Today I will show you that how to run a VHDL and Verilog program in open access simulator, because for a Xilinx and Model Sim is very difficult to download. I have already uploaded one Xilinx and Model Sim, and that is around 12 to 15 GB. So for the student end, they are not able to download this software because the size is very high. So at a time this 12 or 15 GB software download is not possible. So that's why I think that if you can run a VHDL or Verilog program in open access simulator, so you can easily run. So I will show you that how to run. At first you have to type a google.com. After that you just type EDA playground, GROUND EDA playground. So the site is open. So if you click on the EDA playground site, actually the site is very database is very low and the low traffic, and that's why you can easily access this website. If your internet connectivity is not so fast, then also you can access this website smoothly. The website is very light. Now after opening this website, you have to log in. So before login, you have to register your account. So using Google and Facebook, you can easily register your account. If you open your Gmail in another tab, or if you open your Facebook account in another tab, so if you click on this login with Google options, so then automatically through your Google account the account will be registered. So similarly, if you open your Facebook in another tab, so if you click on login with Facebook, so automatically the account will be registered through your Facebook account. And I hope that the students and others all of have you Google and Facebook account, so you can easily register to this Google and Facebook. And another registration process is the full access. So student not able to register the full access EDA playground. So I will show you that what is the procedure to run VHDL or Verilog program. So after login, this window is there, and the right hand plane is there. You have to write the VHDL or Verilog code, and the left hand plane you have to write a test bench. So suppose before that you just select that which language you want to write. Suppose VHDL, lots of languages there: Verilog, VHDL, Python, System C, Perl. So in that case you just see VHDL. So automatically the library declarations and the standards logic declaration is there, so no need to write. So I copy one D flip-flop. And one more thing to remember, that if you copy any code from internet directly and paste it to the simulator, so there may be some issue, some error is there. So it's better that you just type all the codes manually in a Wattpad. After that, step by step, after that you can copy from your Wattpad or Watt file and to the simulator. So I just copy one D flip-flop which I already write in the Wattpad file. So I just copy this D flip-flop program, VHDL program, and paste it to these sections. And similarly I just copy another test bench program after library declaration. So copy from entity portion to the end portion, because already library and other thing is declared there, and I paste it. Fine. So this is your design part and this is your test bench part. So if you want, you can save as a title. Suppose you want to add a title DFF, so I just mention there DFF and click on the save options. Select a valid tool simulator. Okay, one thing that in left hand end one tools and simulator option is there. So if you click on this drop down arrow, there are lot of simulation options. You can see that Mentor graphics, Cadence, Synopsys, lot of options. But in case of VHDL or Verilog, you can choose a basic default simulator, Aldex simulator. So you just choose Aldex simulator and save your program with this DFF name. So after that you have to mention the top entity name. So in your test bench the top entity name is DFF_TB. So if you copy this name and paste it to the entity sections, now you have to select the OpenEP waveform simulator, because after run, if you want to check your output waveform, so that's why you need to click on these options, that OpenEPA wave. So after run, automatically one browser will be open, so in this browser you can easily check your waveform. So again I will click on save option, and after click on this playground options, your playground, you can able to see your previous program. Suppose now in this program I save this program as a DFF name, so after run, if you want to check your program, you can go with this your playground program, you can able to see all of your saved program. So now I click on the run option, so automatically one another tab is open. So in this tab you can easily see that your waveform. So basically in this tab, the clock, DIN, Dout, RST, again clock, DIN, Dout, RST. So we have to remove this clock second portion, clock, DIN, Dout, RST. So now if you verify your timing diagram, so okay, the RST, when RST is 1, basically your output is always 0. So now in case of RST 1, your output is always 0. When RST is 0, output is just follows your input, so you can check that output is 1 where the input is also 1. So similarly, when RST is 1, output is nothing but your input, right? That is the basic working principle of the D flip-flop. So now the D flip-flop is working fine. So if you want to save your waveform, you can also save. Click on the save options. Okay, fine. So this is the platform. So if you share, the concerned faculty, if you share this video, because I have attached all the basic programs like this D flip-flop, one sequential, one combinational, one counter, everything I will add with this video. So you just share this Word file as well as this video to the students, so student can easily understand that how to run the program, basic program, with help of this open access website. Thank you.